Next chapter, factors and multiples. Now let's begin with a multiplication problem. 2 times 4 equals 8. The numbers being multiplied are called factors. The answer 8 is the product or a multiple. The factor next to the multiplication sign is called the multiplier. But let's stick to the term factor. In any case, we could interchange 2 and 4 and still get the same answer. When we express a number as a product of its factors, we say we have factorized the number. So 8 is equal to 2 times 4. So 2 and 4 are factors of 8. But you see, 2 and 4 are not the only factors of 8. 8 is also equal to 8 times 1. And so 8 and 1 are also factors of 8. If we go back to 8 is equal to 2 times 4, you will see that 4 here can also be expressed as a product of its factors, 2 times 2. And so 8 is equal to 2 times 2 times 2. 2 cannot be reduced further. It does not have any other factor except 1 and itself. We call such numbers prime numbers. Here's a list of prime numbers between 1 and 20. 1 is not usually considered a prime number for some technical reasons. All the other numbers that are not prime numbers are called composite numbers. When we express composite numbers as products of their prime factors, we call it prime factorization. Consider the number 60. It is a composite number. We can express it as a product of its prime factors. 60 is divisible by 2. So we have 60 is equal to 2 times 30. 30 is still a composite number. It can be divided by 2 to give 15. So 60 is still equal to 2 times 2 times 15. 15 is still a composite number. It can be divided by 3 to give 5. So we have 60 is equal to 2 times 2 times 3 times 5. 3 and 5 are prime numbers, and therefore we have completely factorized the number 60. We see 2 here is multiplied with itself 2 times. And so we write it as 2 raised to power 2. And then we have times 3 times 5. Now consider 72. At first, 72 is divisible by 2. That's the smallest prime number. So we have 2 times 36. 36 is still divisible by 2. So we have 2 times 2 times 18. 18 is still divisible by 2. So we have 2 times 2 times 2 times 9. 9 is a composite number, but it's not divisible by 2. The next prime number after 2 is 3, and 3 can divide into 9. So we have 2 times 2 times 2 times 3 times 3. And if we write that in power form, we shall have 2 raised to power 3 times 3 raised to power 2. Next, the greatest common divisor, or the GCD. Now, the GCD is also called the greatest common factor, and that clearly says what it is. It is the largest factor that is common to 2 or more numbers. Consider the numbers 6, 9, and 12. If we factorize them, 6 is equal to 2 times 3, 9 is equal to 3 times 3, and 12 is equal to 2 times 2 times 3. The largest common factor is 3, and therefore the GCD of 6, 9, and 12 is 3. When we want to find the GCD of large numbers, we express them in prime factors, and then we pick those common factors. Consider 60 and 72. 60 is equal to 2 squared times 3 times 5. 72 is equal to 2 raised to power 3 times 3 raised to power 2. The common factors are 2 raised to power 2 times 3, and that gives us 12. So the GCD of 60 and 72 is 12. But you might think 2 squared and 3 are only found in 60. But actually, they are found in both. 72 is equal to 2 raised to power 3 times 3 raised to power 2. This 2 raised to power 3 can be expressed as 2 times 2 raised to power 2. And this 3 raised to power 2 can be expressed as 3 times 3. That way, you will be able to see the common factors. When finding the GCD, it is safer to express the numbers as products of their prime factors without the powers, so that 60 will be equal to 2 times 2 times 3 times 5, and 72 will be equal to 2 times 2 times 2 times 3 times 3, so that we can pick the common factors. 2 is common here. Another 2 is also common. Lastly, 3 is common to both. 5 is not common, and so the common factors are 2 times 2 times 3, and that gives us 12. That is the GCD of 60 and 72. Let's look at 40 and 50. 40 is equal to 2 times 2 times 2 times 5, and 50 is equal to 2 times 5 times 5. The common factors are 2 here and also 5. So we have 2 times 5 giving us 10. That's much better. Now let's go to multiples. We said that in the multiplication 2 times 4 equals 8. 8 is called a multiple. Now consider the number 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. The numbers 3, 6, 9, and 12 are called multiples of 3. Any number has an infinite number of multiples. If we take 4, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. And 4 times 5 is 20. The number 12 is both a multiple of 3 and 4. We say it's a common multiple of 3 and 4. If you look at the multiplication table, the numbers inside are the multiples of the numbers in the colored row and column. Now the least common multiple. The LCM of a set of numbers is the smallest common multiple of the numbers. Consider the numbers 2 and 3. These are their multiples. The common multiples are 6, 12, and 18, but the smallest one is 6, and so 6 is the LCM of 2 and 3. To find the LCM of a set of numbers, we first express them as a product of their prime factors, and then we pick the largest factors. For example, the LCM of 8, 12, and 20. 8 is equal to 2 raised to power 3. 12 is equal to 2 raised to power 2 times 3, and 20 is equal to 2 raised to power 2 times 5. The factors present are 2, 3, and 5. The largest 2 is 2 raised to power 3. The largest 3 is the only 3 present, and so we pick it. The largest 5 is again the only 5 present, and again we pick it. And so the LCM is 2 raised to power 3 times 3 times 5, which gives us 120. And so unlike the GCD, for LCM, it is good to express the factors in power form so that we pick the ones with the largest powers. So let's work the LCM of 360, 420, and 500. 360 is equal to 2 raised to power 3 times 3 raised to power 2 times 5. 420 is equal to 2 raised to power 2 times 3 times 5 times 7. 500 is equal to 2 raised to power 2 times 5 raised to power 3. The factors present are 2, 3, 5, and 7. The largest 2 is 2 raised to power 3. We pick that. The largest 3 is 3 raised to power 2. We pick it. The largest 5 is 5 raised to power 3. And the largest 7 is the only 7 present. So we pick it. And so the LCM is 2 raised to power 3 times 3 raised to power 2 times 5 raised to power 3 times 7. And that gives us 63,000. And so in GCD, we pick the only common factors. But in LCM, we pick the factors with the largest powers, even though they may not be common in all the numbers. And lastly, we look at the divisibility tests. Now, when you see a large division problem, the thing most of us do is take a calculator and see if the two numbers can divide. But there is another way of testing if two numbers completely divide. Let's look at the divisibility test for the numbers 2 to 11. Divisibility test for the number 2. A number is divisible by 2 if the last digit is even. For example, 294 is divisible by 2 because 4 here is even. 405 is not divisible by 2 as its last digit is 5, which is an odd number. A number is divisible by 3 if the sum of its digits is also divisible by 3. For example, the number 3,276, the sum of its digits is 18, which is obviously divisible by 3. And so the number 3,276 is also divisible by 3. A number is divisible by 4 if the last two digits are divisible by 4 or are 00. For example, 42,725 is not divisible by 4 because its last two digits are not divisible by 4. 37,164 is divisible by 4 because 64 is divisible by 4. A number is divisible by 5 if the last digit is 0 or 5. 9,425 is divisible by 5, and so is the number 480. A number is divisible by 6 if it's divisible by 2 and 3 as well. The number 216, for instance, the last digit is even, and the sum of its digits is 9. So it meets the divisibility test for 2 and 3, and hence it's divisible by 6. For the number 7, we take the last digit and double it. Then we subtract the result from the remaining digits. If the result is 0 or a number that is divisible by 7, then the number passes the test. Take 413. The last digit is 3. We first double it to get 6. And now we subtract 6 from the remaining digits of the number. We get 35, which we know is divisible by 7. And so 413 is also divisible by 7. Take 84. Doubling the last digit gives us 8. Subtracting it from the remaining digit gives us 0. And so 84 is divisible by 7. A number is divisible by 8 if the last 3 digits are divisible by 8 or are all zeros. For example, the number 57,136. The last 3 digits are 136, which is divisible by 8, and so the number is also divisible by 8. A number is divisible by 9 if all the digits added recursively give the answer as 9. Take 74,916 for instance. The sum of its digits is 27. Now add 2 and 7 and you get 9. And so 74,916 is divisible by 9. A number is divisible by 10 if the last digit is 0. 3,281 is not divisible by 10, but 23,540 is divisible by 10. For the number 11, we add all the digits in the odd number places and add all the digits in the even number places. We subtract the result. If the result is 0 or a number divisible by 11, then the entire number is divisible by 11. Take 75,152. The sum of digits in odd number places is 2 plus 1 plus 7, which is 10. The sum of digits at even number places is 5 plus 5, which again is 10. The difference is 0. And so the number 75,152 is divisible by 11. Again in 21,824, the sum of the digits at the odd number places is 14, and the even number place value digits add up to 3. The difference is 11, and so 21,824 is divisible by 11.
One of the wonderful things about mathematics, I think, is that people are impressed. It's often seen as a very hard subject, and so if you've done math, it's often treated as an entrance requirement, as a credential to do lots of other things. And so one idea is that for example, some MBA programs, the only thing they require going into it is a good, solid math understanding. They can teach you all the business, they just can't teach you the math fast enough. And so I think that math, aside from obvious careers that require math, if you're going to go work in a department that does operations research or something like that, they'll want people with specific skills in mathematics. But math is often seen as a filter, as a screen for many, many other disciplines. And so I guess what I'm trying to say is you can think broad because math actually is a solid preparation. It's a good credential to go into lots of different fields that people often don't consider at the beginning.